30. Actually this is left side clockwise, left side clockwise positive, so 5 minus 25, and after C points there is no moments, so draw shear force diagram, bending moment diagram. This is this, and first before a 0 bending moment at B, this is negative signs, this is negative minus 30. Before C, this is constant 30, this is C point. This is point C, this is point C, this is point C, and at C, before C, this is 25, and this is 25. If when the shear force diagram is constant, this is inclined straight line, so this is inclined straight line. Here also 30, so there is another moment we have not considered. Sorry, there is a big mistake by me, and this also here before C minus 30 into plus, this is clockwise. Suppose bending moment before B 0, bending moment at B is 30, this is counterclockwise, counterclockwise negative. Okay, there is a before B there is no moments, so there is this point load into 2 plus, this is clockwise positive, plus 5 into 2, this is minus 20 before C, minus 20 at C, minus 20, this is clockwise, plus 5 equal to minus 15. Okay, and bending moment at A is, there is no moments. Now counting left side, there is no moments, so 0. Suppose bending moments at before B 0, at B is minus 30, before C minus 20, before C minus 20, and this is minus 15, and at C is, and at A is 0. So we know when shear force is remains constant there, and bending moment diagram is, this is minus 20, this is minus 20, this is 20, this is minus 15, and here 0, and there 0. So if constant, the inclined shear bending moment diagram is inclined straight line, and here a moment is acting, so sudden jump in the bending moment diagram 20. Understand that this is, so maximum value of bending moments max equal to minus 30 kilonewton meters at point B. At point B. Now another problem is this is simply supported beam. This is hinge joint and here is roller joint, and UDL acting. UDL is acting. This is 20 kilonewton per meter. UDL, intensity of loads, and this is points A, this is point C, this is point B, and here another point D. Here a point load, this is point load, is 20 kilonewton, and this is distance A to C, 2 meters. This is 1 meter. This is also 1 meter. Now first calculate maximum. Question is M max. Question is, now draw FBD, free body diagram. Here hinge joints. So RA hinge joint, there is two reaction force, RAX, RAY, and here is 20 into another point, 20 into, this is 2 meter into 2. The load into total distance, this is the loads, and acting 1 meter from A. Centroid of, this is centroid of UDL, and there is 1 meter, there is 1. Here is point load 20 kilonewton, and roller joint only there is reaction force, one reaction force. This is 1 meter, this is 1 meter, 1 meter, 1 meter. This is the, and now calculate the reactions, magnitude and direction of magnitude. Here now static equilibrium condition, summation of Fx equal to 0. So there is only horizontal reaction, horizontal force, so equal to 0, and summation of Fy equal to, this is vertical, upward force is positive, so we can say Ra equal to, we know Ra equal to summation of Rax square resultant force Ray. Here this is 0, so Ra equal to Ray. So upward force, this is downward minus 40, this is also downward minus 20, this is upward Rv equal to 0. Upward positive is taken as a positive, Ray equal to Rb equal to 60. Now summation of Ma equal to 0. Counterclockwise negative, Rb into 4 minus 20 into clockwise sense and distance is 3, and this is 40 into this is clockwise sense, so positive 1 equal to 0. Oh, this is also clockwise sense, so positive sign. So RB equal to 60 100 into 25. So this is equation number 1, this is equation, and put the value RB in equation 1 and get RAY equal to 35 kilonewton. This is 35 kilonewton, and here RB equal to 25 kilonewton. At point this is reaction force 35, and at B. Now calculate shear force. Shear force at point load twice. Shear force before A is 0. This is shear force sign convention for shear force. Left right, this is positive clockwise sense, upward left side, and this is counterclockwise negative left right shear force. And now left side is positive, left side upward is positive. Shear force at A equal to positive 35 plus 35. Now here is shear force at before B. Here also a point load, so calculate twice shear force before B equal to 0. Shear force at B equal to right side. Now calculate B is right side upwards. Right side upwards, sign is negative and the load is 25. Now shear force, here also a before point load, so before calculate shear force twice. Before D constant 25, shear force at D minus 25, right side, the calculated right side from right side, so right side downward positive, so positive 20 is minus 5. Now draw shear force diagram. SFD. This is point A, this is point D, this is point B, C, D. Now before A is 0, shear force at B plus 35. Now shear force before B is 0. Shear force at B minus 25. Shear force before B also 25 minus 25. Shear force at D minus 5. And there is no shear force, so this also constant. Now, and when UDL, the shear force diagram is inclined straight line. Shear force diagram is inclined straight line, between inclined straight line. And joined these 2 points up to D. Sorry, big mistake. Sorry. Up UDL up to C. Here. Now this is constant. Now first shear force before A 0, shear force at B 35. Shear force before B 0, shear force at B minus 25. Before D this is constant 25, and at D minus 5. So here no force, so this is constant, this is E, and there is no force, so shear force is constant, and this is minus, and this is 5, also 5, this is minus. Now join, this is minus, so join both of them. Suppose this is point E, this is positive sign, this is negative sign. Now here shear force is 0, so we can say the bending moment value is either positive or negative at this point is point E. Suppose this is point E. Now you can easily calculate the maximum bending moments from this diagram. And now we triangle similarity, suppose condition. Suppose this point from X is E point is assumed X distance, so this is 2 total, so point CE AE equal to, suppose assume X, so EC equal to 2 minus X. Now applying triangle similarity, 35 into distance X, and here 5 into 2 minus X, so 5x into 70 minus 35x, 40x equal to 70, so x equal to 1.7 meters. Here bending moments is maximum. Here we know another point, bending moment at any section, suppose this is a section, distance X from A, this is X, at a section is equal to area of shear force diagram, at that section, up to that section, up to that section. Again we know dm equal to dx equal to v. So m equal to v into dx, dm equal to df, and integration dm. So area bending moments equal to area of shear force diagram up to that section. So this is up to that section. So bending moments up to E points, this is half into, this is triangle shape, so half into height, the base 1.75, this is 1.75 meter into 35. So value is, calculate 30.625 kilonewton per meter. This is maximum value of, so maximum bending moment 30.625 kilonewton meter. Now and draw bending moments diagram. Suppose here bending moments at A equal to 0. Bending moments there is no moments. Bending moments at B equal to 0. This is sagging, positive, left right. This is counterclockwise, negative, left right. Bending moments at D points. From left side, this sense is counterclockwise. Right side counterclockwise is positive. So force 25 into distance 1 meter, 25 kilonewton meter. And bending moments at C from right side. This is anti-counterclockwise, right side counterclockwise, positive 25 into 1. This is right side clockwise, negative, minus 20 point at a 2 distance, at 2